welcome to Notes on Function Composition and Decomposition. We are going to be talking about composing functions together. So we need to remember that functions are amazing because they perform an operation based on a specific input in order to get an output. So using that definition, we'll look at composition of functions. A function, like h of x, has an output that has the output of one function, g of x, as the input of another function. So this is best described by looking here in this equation, where g of x is acting as the x, so the input for f of x. For this set of notes, it is going to be a little bit helpful as we go on, not now, but to use different colors. If you have them, I'd grab some. I wanted to include kind of a goofy abstract example based around success. Here is your productivity and then your distractions, and they're going to compete with each other to basically achieve something, whether that's doing well at school or at your job or anything like that. And I've generalized the productivity here and distractions as success. So we've got a success function, a productivity function, and a distraction function. And if we were going to look at all the things that make up productivity, so good sleep time is obviously helpful to productivity. There's job time that we need to consider, homework time, and all those things, when you put them together, they're the inputs for the time you're taking to be productive. And the same goes for distractions. You've got maybe too much sleep time and maybe too much phone time that contribute to your distractions, and together, as we've learned with combination of functions, they contribute to your success. So we can talk about different examples that are more engineering based, but I wanted to provide an abstract example here. With pre-cal examples, it's very important that you notice the input variables and the operation directly affecting that input when we look at these. And I'll remind us. These variables help us group functions, which is how we're going to use them in compositions. So starting off with this left side has an input that's on the very inside function. And with these, we're going to work inside out. If you're given a specific input, so a number, for example. So what we're going to do is, well, first of all, I'm going to highlight f of x. I'm going to use red there. I'm going to use pink for g of x, and I'm going to use blue for h of x. So f of g of 0. Well, what is g of 0? G of 0 is 0 squared plus 1, because I've put 0 into my pink function. And then now I need to solve what's f of 0. F of 0 is equal to 3 times 0 plus 4. So that equals 4. Got it. We're done. So we're taking the output of g of 0 and putting that into f of x's input. B is going to work similarly, except we're going to start off by putting 0 into g of x. So I'm going to take g of what is f of x doing, 3 times 0 plus 4, and that's going to give me 4. So what is g of 4? G of 4 is equal to 4 squared plus 1, so 17. Alright, and for the last ones, we are going to do the same thing, except this time we're going to use a graphical representation for each. And here are the graphs for C. Right here we've got f of g of 2, where this right here is g of x, and this here is f of x. And I'm going to take g of 2 and use that as the input for f of x. So g of 2 is 5. And now I want to ask the question, what is f of 5? And I look over here at my graph of f. F of 5 is 19. So here my answer is 19. So I'm just looking at the y values because those are the outputs. X values are my inputs. And then for D, I want to know what g of f of 1 is. Here's my g of x. Here's my f of x. If I look at f of 1, f of 1 is equal to 7. And what is g of 7? Because I'm using 7 as my input for g now. G of 7 is 50. Awesome. So we can find those values from graphs if we use them as well. You're welcome to do those algebraically if you're given the equations, but if we're not given the equations, then we can solve them with graphs. On E through H, these are a little bit more abstract because they're generalized. And we will not be working inside out. Instead, we'll just be using the outside function first, and we'll be leaving a gap. So f is my outside function, and I'll be writing 3, leave a gap for my variable, because we know our variable is not x. This used to be x, but it's not. This has to be g of x, because that's what we're told in our equation, in our composite equation. So this has to be x squared plus 1. And then we're not going to leave it like this. To finish this off, we're just going to distribute and combine like terms after distributing. So then we're left with 3x squared plus 7. And that's our final answer. That is f of g of x. For f, we're putting f inside of g. Now, if you want to try G and H and see if you get the same thing that I do. Alright, so there we have it. I've got my final 2 examples finished. Make sure you are performing these operations appropriately. The 3 down here does not distribute to both the numerator and the denominator. It just distributes to the numerator. And then we can't combine any terms here because we've got a fraction with an uncommon denominator to the fraction that is 4/1. And that's it for the notes. There is a decomposition video that goes along with this one if you're in advanced.